Hello, everyone. It's Mr. Kissinger at the Citizenship Academy in Syracuse, New York, and this is 5th grade math, Module 5, Lesson 8. We're going to apply concepts and formulas of volume to design a sculpture using rectangular prisms with given parameters. So we're going to kind of be applying those ideas that we about volume that we've been learning about. So this table here. It says for number one, I have a prism with the dimensions of 6 centimeters by 12 centimeters by 15 centimeters. Calculate the volume of the prism and then give the dimensions of 3 different prisms that have 1/3 of the volume. So the first thing I'll do is I'm just going to draw my prism here over in the kind of the margin here. So draw a rectangular prism. All right, so there's my prism. And I have a length of 6, a height or a width of 12. I probably made it a little bit too big. We'll shorten it up a little bit. Doesn't have to be exactly a scale, but I want it to be that. That kind of makes sense. All right, so we have this side is 12. And then this height is 15. So if we do 6 times 12 times 15, we can do that a number of ways. First, I guess we could do 6 times 12. That might be the easiest one to start with. And I'm going to use an area model for that. So I have 6, I have 10, and 2 for 12. 6 times 10 is 60. 6 times 2 is 12. And I add those together and I get 72. Then I have to do 72 times 15. And I'm definitely going to use an area model for that. So I'm going to go down here. This time I'm going to need 4 boxes. I have 70 and 2 and 10 and 5. So 70 times 10 is 700. 10 times 2 is 20. 70 times 5, well, 7 times 5 is 35. Times 10 is 350. And then 5 times 2 is 10. When I add those together, I'll get 700 plus 350. Well, 700 plus 300 is 1,000, plus the other 50 is 1,050. And then 20 plus 10 is 30. Add those together, and I get 1,080. So I'm going to have a volume of 1,080. It's going to be cubic centimeters. All right, so I need to make a 3 different prisms that'll each have 1/3 of the volume. And I think the first thing that I'm going to do is I'm going to figure out what 1/3 of 1,080 is. So let me make sure I get everything right there. Okay, oh, that's right. All right, so 1,080 divided by 3. So I have 3 goes into 10 3 times. So give me 9 left over, or 9 with 1 left over. Bring down my 8, I get 18. And 3 goes into 18 6 times. and then I get 0. When I bring down my 0, 3 goes into 0 0 times. So I get 360. So 360 is going to be 1/3 of the volume. So they're all going to be 360 centimeters. That's what I'm using right now. So what I can do if I want to find a third of my total volume is I could just divide one of these numbers by 3. And what's nice is actually all 3 of those numbers are divisible by 3. So if I take my 6, for example, 6 centimeters, and I can make that 2 centimeters, I keep my other 2 the same, get 12 centimeters and 15 centimeters. I can do 2 times 15 would give me 30, and 30 times 12, well, 3 times 12 is 36, times 10 is 360. So because I was able to divide one of my dimensions by 3, my total volume will end up being 1/3 of the original volume. I'm taking away 3 layers, not just 3 centimeters, but 3 layers of that prism. So I could do that in any dimension that I want to. So I can leave this one 6. And let's say I divide my width by 3. Well, I could make that 4 centimeters. And then I keep this one 15 centimeters. 4 times 15 is 60. 60 times 6, well, 6 times 6 is 36, times 10 is 360. And finally, I can keep these all the same. I can do 6 centimeters, and this one will be 12 centimeters. And finally, we have 5 centimeters. And 5 times 12 is 60, times 6 is 360. So I just divide any one of my dimensions by 3, and I'll end up with 1/3 of the volume. So number 2 says Sunny's bedroom has the dimensions of 11 feet by 10 feet by 10 feet. Her den has the same height but double the volume. Give 2 sets of possible dimensions for the den and the volume of the den. So we have 11 by 10 by 10. And so if 10 is our height, we know that needs to be the same. So we have length times width times height, which is 10. That is the same. I'm going to put H in parentheses here so we know that's our height. Equals our volume. Well, first, if we do 11 times 10 times 10 to figure out the dimensions of our bedroom, well, 11 times 10 is 110, plus times another 10 is 1,100. Just add 2 zeros because I'm multiplying by 10 twice. So it's going to be 1,100 square cubic feet. And then I have a length and a width times 10 will have to be, no, but it needs to be double the volume. So it's going to be 2,200 square feet. Cubic feet, I should say. So we're talking about volume. So we have length times width times 10 equals 2,200 square feet. So I could simply, if I wanted to double my volume, I could double one of my dimensions. So let's double 11. We could do 22. times 10 times 10, and that would equal 2,200 or 20,200 cubic feet. I'm going to say 1 is 22 feet by 10 feet by 10 feet. And I could also double my other dimension. I know I can't double this 10 because that needs to remain the same. But I could do for my second one, I could do 22 feet. Oh, actually, it'd be 11 feet because we're keeping that one the same this time. 11 feet times 20 feet, so I'll double the second one, times 10 feet. 11 times 20 is 220, times 10 is 2,200. So there are my two different dimensions that den could be. And then our volume is 2,200 cubic feet. All right, so that's all we have for today. Thank you guys for tuning in, and I look forward to seeing you next time.